In this lesson, I'll be going over how to add and subtract complex numbers. So again, remember our complex numbers are in the form of that a plus or minus bi. So we can write our complex number as a plus bi or a minus bi, where if you recall, our a, that is our real part, and b, notice how being the coefficient of I, is going to be our imaginary part. So before we get to the adding and subtracting our complex numbers, we're going to first focus on making sure that we identify those pieces to identify missing pieces in an equation. So for example, looking here at the first example, if we are going to solve for x and for y, notice in the equation what we're going to do first is we need to identify what are those real parts, right? What are the imaginary parts? Because that is what we need to set equal to each other. So in this case, looking on the left side here, right? Notice how we have 3x is our real part. So I'm going to have 3x. Then equal to, notice now on the right side, our real part is 9. Now I can go through and just solve. Well, you would just divide by 3, and x is equal to 3. Now, if I'm identifying and solving for the imaginary, again, notice how the imaginary parts are the coefficient of I. So here I've got on the left side of my equation, 12i. 12i is equal to, notice how that is a negative 4yi. So now notice, thinking about it like this, if I were to notice how we have I on both sides of the equation. So here, if I were to first, if we're trying to solve for y, notice that I would divide by not just -4, but -4i, right? Because that's what's being multiplied to y. So I'm going to divide both sides by -4i. Then here, that's my positive 1. I divided by I, 1, cancel out. So then notice, we're not going to be left with I in our answer now because we have I divided by I. I divided by I is 1. So really, we just have 12 divided by -4, which is -3. So notice again, to solve for x and y in these equations, make sure you identify the real parts to set them equal to each other and the imaginary to set them equal to each other and solve. So again here, let's focus on the real of this next example. So looking at the real on my left side of my equation, I have multiple real parts. I have 8x and -7. So 8x minus 7 is equal to. So now on the right side of the equation, the real part here is 9. Notice how? No imaginary part. Now we can go through and solve. I'm going to solve it like a two-step. Add the 7 to both sides. 8x is equal to 16. Divide by 8. And you get x is equal to 2. So now let's do the same thing, but with our imaginary. So again, on the left side of the equation, we have positive 24yi. So we have 24yi. And then on the right side, we have negative 12i. Notice how we are solving for y, and it's being multiplied. So we're going to divide by 24i. What we do to one side of the equation, we need to do to the other. So now cancel out to get 1, but even I divided by I is 1, and here's our y. And then again, I divided by I is 1, so they cancel out. Now notice that's negative 12 over 24, so that's -1/2. So go ahead and pause the video here and try these on your own. So make sure, right, to set the real equal to each other, set the imaginary equal to each other, and solve. And here we go. So let's go ahead and first focus on the real part. Oops, sorry about that. Let's first focus on our real. So on the left side, your real part is 2x. 2x is equal to the real part on our right side, which is negative 8. Now we solve for x. Divide both sides by 2, and x is equal to negative 4. Then same thing for the imaginary part now, right? So we're looking for that coefficient of I. So on the left side, again, you have not 6i, but negative 6i. That is equal to, on the right side of the equation, positive 12i. Now we can go through and solve, but now for y. Y is being multiplied by 12i, so divide by 12i. Remember, our 12 is 1, and I divided by I is 1. Y is equal to, our i's cancel out to give you 1, and you're left with negative 1/2. Now let's go to D. So same thing again. Let's focus on the real part. So on our left side of our equation, we have 4x, but also plus 13. So 4x plus 13 is equal to, on the right side here, we have positive 5. Now we can solve our two-step. Subtract 13 from both sides. You have 4x is equal to negative 8. Then now divide both sides by 4, and you have x is equal to negative 2. Now let's do our imaginary part. Here we go. So again, working with our imaginary, on the left side of the equation, we have just 7yi. So 7yi is equal to, so on the right side of the equation, our imaginary part is negative 21i. Now again, notice we're solving for y right here, which is being multiplied by 7i, so divide by 7i. That gives you 1, here is 1. Y is equal to, again, remember, right? I divide by I is 1, and you're left with negative 3. Now we're going to get into the adding and subtracting, so the sum and the difference. But again, the whole purpose is making sure to combine like terms. So again, we need to make sure to identify the real because you're only going to combine the real. You're only going to combine the imaginary. You're going to combine like terms. So like if I have a plus bi plus c plus di, a and c are the real parts. So that means we would add a plus C together, right? Plus, then you would add together the imaginary parts, which here are BI plus DI. So notice how you are combining like terms. You need to keep the real again together and identify and combine your imaginary parts together. Then here the difference, notice and remember with this tip, if you have minus, right? So minus C plus DI, this here, just like this, is the same as, think about it as what you have here is that minus, which is a negative 1. And then if I distribute that negative 1 times A, negative A. Negative 1 times BI, negative BI. So here, if we wanted to do the same thing, right, you would end up with, so A plus BI, but then distribute the negative. So now we're adding, but now negative C, right, minus BI, because here you're distributing a negative 1. Then you end up combining your real, which are A, but now plus that negative C, and then the imaginary, again, you need to keep together, which are BI, but now minus BI, or plus that negative DI. So keep in mind, if we have subtraction, we're going to distribute that negative 1 before combining like terms. So looking at these examples, make sure that you identify the operation. So if we need to distribute, we remember to distribute. Notice how we're adding. So we're just going to go through and combine our like terms. So with our real parts are 4 plus negative 6. 4 plus negative 6 is negative 2. Then we now combine the imaginary parts together. 2i minus 7i. 2i minus 7i will give you negative 5i. So the final answer is negative 2 minus 5i. So again, notice that we are just combining our like terms. Now notice with the second example, we do have a negative here. So let's distribute that negative 1. So I'm going to bring down 5 minus 2i, but now plus positive 2 plus 3i from distributing that negative 1. Now we can combine our like terms. Our real, so 5 plus 2, 5 plus 2 is 7, and then our imaginary, which here are negative 2i plus 3i. Negative 2i plus 3i now gives you 1i, or remember, that can just be written as I. So our final answer is 7 plus I. Now notice we have multiple here, right? So just work it left to right. The first here, we're just adding. So that we can just combine our like terms. We have 12 plus 7. That is your real. 12 plus 7 is 19. Then we now combine the imaginary. 5i minus 9i, or 5 plus negative 9i minus 4i, because that's going to give you negative 4. Then I'm going to bring down minus 3 minus I. Now, because we're subtracting, think again, that's a negative 1. So let's distribute that negative 1. 19 minus 4i plus negative 3 plus I after distributing and multiplying by negative 1. Notice how we're just changing the signs. Now, just like before, combine your like terms. We have our real, so 19 plus negative 3. 19 plus negative 3, 16. Then here are imaginary. Negative 4i plus I. Negative 3i, because that is negative 4i plus just I, which is technically 1i. So notice how negative 4 plus 1 is negative 3. So negative 3i. Final answer for your complex number. So go ahead now, pause the video, try the U-tries, and then let's see what you get here. And here we go. So let's combine the real. You are adding. So 1 plus negative 1. Well, that's just 0. So really, we end up with no real part because 1 plus negative 1 is 0. Then here we have negative 3i plus 3i. Well, negative 3i plus 3i. Well, negative 3 plus 3 is also 0. So guess what? The answer here is 0. 2e. Notice how you do have minus like a negative 1. So let's first distribute that negative 1 here. So I'm going to bring down 4 plus 7i, then now plus, but instead of positive 4, negative 4, and then plus 7i. Now combine like terms. Here I've got 4 plus negative 4. Well, again, that just gives you 0. They just cancel out. Then now I've got 7i plus 7i. Well, 7i plus 7i is now 14i. With 2f, work it left to right. So notice how first we are going to add. So combining like terms, we'll notice how with the real, there is no real. So I'm just going to bring down my negative 3. But here you do have to combine 5i plus negative 6i. That gives you negative 1i, or just negative I. Now I'm going to bring down minus 4i plus 8. Notice again, we are subtracting. So let's distribute that negative 1. So here we've got negative 3 minus I. Then plus now, instead of positive 4i, negative 4i minus 8. Now we can identify our like terms to solve. Negative 3 minus 8. Negative 3 plus a negative 8, negative 11. Then here, negative I, negative 1i plus negative 4i, now you have negative 5i. And so as I scroll down here, sorry about that, I just realized that was cut off, you end up with the answer of D. Now with 2G, our last question here, we're looking for what value does B need to be to make this statement true? Well, first off, we need everything to be pretty, right? Think about like addition. So I'm going to first rewrite the left side here, see how we're subtracting, and let's go through and distribute our -1, just like how we would before. So I'm going to bring down my -5 plus 2i. Now we're going to rewrite this as adding -5 plus bi, right? So now notice when we add our like terms, -5 plus -5 is -10. So now we're thinking 2i plus bi is equal to 3i because we need to keep all of our imaginary together, just like earlier in our equation. So if I have 2i plus bi is equal to 3, then what does b have to be to give us that value of 3i? And the answer is 1. Because here if I have 2i plus just another 1i, 2 plus 1 gives you your 3i.